Good morning, my name is Paweł Osłoń and I would like to present the presentation entitled Urban Integration of Renewable Solar Energy Sources and Heat Storage RESHeat. The authors of the presentation are Paweł Osłoń and Mehmet Ali Yildirim from Cracow University of Technology, Professor Petar Sabew-Warbanow and Professor Jiří Jaromír Klemeš from Brno University of Technology and Professor Wiesław Zima from Cracow University of Technology. So, at the beginning I would like to introduce the RESHeat project, which is Horizon 2020 funded project, residential energy system for heating, cooling and electricity production for buildings. The idea of the project is to develop the zero emission and autonomous energy system based only on renewable energy sources. The RESHeat is an energy generation system, hence using renewables, allows to produce electricity, heat and cooling for residential, public utility and commercial buildings. The system consists of sun-tracked PVT panels and sun-tracked solar collectors. They are producing the heat. Low temperature heat is produced by sun-tracked photovoltaic thermal panels, which is stored in the boreholes and in underground heat storage tank, which is non-insulated, and transfer the heat to the ground in summertime, and then it gets it back in the winter time during the heating season. The sun-tracked solar collectors are producing high temperature heat, which is stored in the insulated underground heat storage tank and which is used for domestic hot water preparation. We also use the waste heat from sun-tracked solar collectors and sun-tracked photovoltaic thermal modules to regenerate the ground to the borehole heat exchangers. The application of underground energy storage unit allows to increase the heat pump COP, therefore less electrical energy is needed to deliver to power the heat pump compressor. Also, what is important, by cooling the PV panels, we are able to increase the efficiency of the solar to electrical energy conversion. The key component of the system is sun-tracked PVT panel. So we have developed the cooling system for these PV panels with Elfran company, and it was done during the National Research and Development Project HISOL. The designed modules are universal and be able to be applied for different types of PV modules, and also we developed the new drive for PV sun tracking. The first demo pilot installation has been made in District Fire Station in Oświęcim, Poland. It is possible to see it here. We have 9 kW stationary cooled PV modules and 9 kW sun-tracked PV modules to compare the differences and the efficiencies. What is possible to draw the conclusions from those investigations is that the sun tracking increases the average annual electricity production by about 54.8 kWh per square meter, an increase in energy yield of about 34% over stationary PVT modules, and increases thermal energy yield by 172.6 kWh per square meter, an increase of more than 85% over the stationary PVT modules. We obtained a low temperature heat of 35 to 40 centigrades. And we used those sun-tracked PVTs and sun-tracked solar collectors coupled with underground energy storage. The project has been done by Chamara company with Cracow University of Technology and Elfran company as the subcontractors, using the National Research and Development Fund SOPSAR project. And here we can see how it looks like. We have sun-tracked PVT modules, sun-tracked solar collectors, stationary PVT modules, and underground storages, which are installed here under the sun-tracked PVT modules. And the major conclusions which we can draw from the system efficiency analysis is that the heat pump COP is over 5.6, and the system allows to cover electricity demand, heating, and heat demand from renewables. The seasonal thermal energy storage using underground heat storage tank is applied to achieve this goal. We are just making the demo site in Cracow. We can see here the PV panels installed on the roof of the building, as well as the Suntract solar collectors will be installed also in the near future, and underground energy storage unit. The location is in Działkowa 26 at Kraków in Nowy Bieżanów. The year of the construction is 2013 and the number of apartments 24. We are replacing natural gas boiler with the heat pump system, and during the project it will be possible to compare heating costs before and after the modernization, because we have the same size building. What is important, we are using these components of the system: Suntract PV modules, Suntract solar collectors, stationary PV modules, and underground storages. Also, we are using the borehole heat exchangers. The electrical power output is 40.8 kilowatts, and thermal power output is 36 kilowatts from Suntract solar collectors and Suntract PVT. Also, the heat pump thermal power output is 95 kilowatts. The underground storage 50 cubic meters and 15 boreholes with 100 meters each length will allow us to cover 100% of the heating energy demand. We use water-to-water heat pump, ground source heat pump produced by Oilon company. In Działkowa, we are doing this demo site for 24 apartments. In Limanowa, we are doing it for 9 apartments. The natural gas boiler is also used. The building was built in 2017. The heating system is a little bit better. The radiators are oversized, so it would be possible to obtain higher COPs than in Cracow. We suppose we have installed solar collectors, PV panels, and actually we are installing the underground thermal energy storage unit. So what is possible to observe by using this underground thermal energy storage unit? We can cover up to 90% of the building heat demands, and the system is fully based on renewables, allows heat pump COP over 4 consecutive heating periods, and the system will be demonstrated in Poland and Italy. We are also planning a demonstration for Palombara Sabrina location. It's nearby the Rome city, 13 apartments building. The target TRR level is planned to be 8, and we need to introduce the RESHeat to the market. What we would like to tell is also that having the economic analysis for Cracow demo site, which has the building energy demand of 150 megawatt hour yearly, and assuming actual cost, we get the positive NPV value after 3.2 years compared to the heat pump system, ground source heat pump system, and 6.8 years compared to natural gas boiler. However, in winter time there is a significant increase of fuel cost expected, especially for the natural gas, because it's expected to increase even tenfold. Therefore, the unit energy costs are also significantly increased, so the net present value positive can be obtained after 1.5 years compared to the gas boiler system, as well as over 2.5 years compared to the heat pump system. Therefore, the unit proposition, the System serves up to 90% single-family building and 70% multi-family building of the heating needs. Cogenerates power, delivers high energy independence, is fully renewable, provides high security of energy supply. The expected positive NPV value is after 4 to 5 years. Is feasible even for Polish climate, which is relatively cold. The solution can be a scalable system, allowing the application for all climatic conditions, and is an opportunity for the industry and small-medium enterprise companies facing energy transition. There are multiple applications in buildings, small industry and services, and agricultural like farms and greenhouses. We are welcome to visit our website. There is also movie about the RESHeat project prepared by Cracow University of Technology and Municipal Buildings of Cracow. In the conclusions, I would like to underline that the RESHeat system is a flexible and adaptable system for combined heat and power. The two temperature levels of hot water in heat accumulator and insulated hot water storage tank are used. Can cover up to 70 to 90% of the heating needs, adding power, electricity supply. Renewable energy integration is also possible into total sites consisting of small industry and municipal actors. For this, we will also study the application of RESHeat system. It allows high supply security and independency, and is excellent replication opportunities in multiple applications. For further information to model components of the system, I encourage to read the Renewable Energy Utilization Using Underground Energy Systems book, as well as to study similar the components and renewable energy approaches to buildings. We have published some papers in Energies, Renewable and Sustainable Energy Reviews, as well as in Energy and IEEE. So I would like to thank for your attention, and this research is funded from Horizon 2020 project under the grant agreement number 956 and 255. Please contact me if you have any queries or questions. And thank you very much for your attention. Here we are presenting Brno University of Technology. It's possible to see the beautiful city and also the beautiful city of Cracow. Thank you.